It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging gate contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with a test.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for gate till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack gate deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate gate challenge. Unacademy Combat. Register now.
So very good morning to all my dear friends. So just now you have seen our Unacademy Combat as well as our iconic plan details. Okay. So good morning to all. Once again welcome to Unacademy. So कैसे हो मेरे प्यारे दोस्तों? Okay. चलिए. So दोस्तों मैं हूँ आपका दोस्त ऐश्वर्य. पढ़ाता हूँ आपको गेट ईएससी के लिए. आई हैव डन माई मास्टर्स फ्रॉम आईआईटी दिल्ली एंड बीटेक फ्रॉम जामिया मिलिया इस्लामिया. 4 times I have qualified GATE with my best AIR 226, and I do have 7 years of teaching experience and 2 years of industrial experience. Okay, these are the subjects which I am basically taking on Unacademy official YouTube channel, Unacademy special classes, as well as on Unacademy Plus. The subjects are Theory of Structures, RCC, Geotechnical Engineering, Strength of Material, Engineering Mechanics. All these are the subjects. And let me come over this code #10, which you can apply before buying any Unacademy Plus subscription. Okay, and do not think that this code is only valid in GATE and ESC. You can consider this code as a universal code at Unacademy. Means no doubt you can use this code in GATE and ESC department and you can avail the benefit of 10%. But also you can promote this code among your friends and relatives for various other competitive fields like you can say SSC JEE, Civil Services, IIT JEE, NEET, CBSE, CLAT, CAT, etc. All these segments it is valid. Okay. And whatever may be the branches, you will be getting 10% off. by using this code. Okay. Now the thing come, why do we need Unacademy Plus? So at Unacademy Plus, we are giving you daily live classes, crash courses, weekly test, doubt solving session, English and Hindi, both the languages courses are there, and rank improvement batches are also there. And if you simply want to convert this plus experience into your personalized coaching, then you can go for our iconic plan, which is a superset of plus. And in iconic, we are going to give you all this feature of plus, but apart from that, we will be giving you a local guardian, which is also known as your personal coach at Unacademy, who is going to plan your studies, who is going to keep the study booster session for you, who is going to analyze your test at the personalized level. And not only this, you will also be getting some specialized notes and practice sets. Okay, so whether it is a matter of plus or iconic, so do not forget to use my code. Okay, you will be getting benefit by 10%. Is it clear? Okay. Now next, friends, here are some details on our recently launched batch for GATE 2022. So batch E for GATE 2022. Okay, batch E is there for GATE 2022. It started on 22nd of February, and you can use code #10 here to be a part of this. Okay, and if you are targeting for GATE 2023 a 2-year program, or if you are in 3rd year like that, then again you can go for our Ascent batch, which is also the 5th batch here. Okay, a very good morning Shamala. So it also started on 22nd of February. This batch has also initiated by our top educator, and here you can use the code #10. Is it clear? Okay. So you can also check this small, you can say, can get your subscription in these batches, and you can use my code. Okay, now prelims batch B we have launched on 18th of Feb. Okay, so here as well you can use this code and you can be a part of this, because in non-technical things, these general study, you can say in engineering services, this general study thing is going to make a huge difference in your rank. Actually they are your rank deciding things. Okay, so you have to go for one dedicated batch for general studies. So even if you are thinking that you are okay in technical and you want to give this year ESE, you can go for our this batch. Is it okay? So even now, till now, you have not downloaded the Unacademy learning app, then you can download it from App Store, or you can say from your Play Store. And after downloading, you can use this code as an invite code. Okay, and by that you will be able to unlock your these 4 accessories: special class quizzes, live test series, Unacademy combat, like that. Okay, chaliye. So now start the session number 23, and session is really very important. Topic for today class is FlowNet. Okay, so you can say it is the last topic of CPA chapter. So after today we will be closing this as well. Okay, after today we will be closing this as well, isn't it? So this is, you can see, the last chapter of last topic of C page. Okay, so FlowNet. Okay, so what do you think of FlowNet? Tell me. Any idea to anyone? Any idea to anyone? Okay. See, I'll tell you. There is a Laplace equation. The Laplace equation is like kx, okay, you can say del square h by del x square plus ky, okay, del square h by del y square is equal to 0. This is known as the Laplace equation for the flow of water for an isotropic soil. Okay, this is for an isotropic soil. Okay, but what happens if your soil is homogeneous and isotropic? In that case, what will happen? Your kx, ky same for your isotropic soil. Then you can write it like this: del square h over del x square plus del square h over del y square. This is equal to 0. So this is your for isotropic soil, isn't it? So what is h? H is head. What is x and y? X and y are the dimensions. So you can say water is flowing in the xy plane. Kx and ky were the permeability. Okay, when both of these permeability are same, then we can take this permeability thing common out of here, and then we can write this differential equation. Is it clear? Is it clear? Tell me any doubt? Okay. Saman Kumar, is it not clear? My dear Saman, see, it is the continuation on C page, and I have just told you a mathematical Laplace equation which is going to define your flow within the soil with respect to, you can say, boundary condition. Some timings are from morning 8:30 to 9:45. Morning 8:30 to 9:45. Okay. Yes, one announcement I would like to make today. Tomorrow, I am not going to take class at 8:30 a.m. in the morning. Although from Monday to Friday, I do have class at morning 8 o'clock, 8:30 o'clock. But tomorrow, Mridang Saurav sir will be taking your classes dear in the morning slot. Okay. So he will be continuing with his lecture, and otherwise you can say from on the daily basis, Monday to Friday, I will be watching you in the morning 8:30. Okay. Yes. So yes, so someone we can see that it is just a graphical solution. It is just a graphical solution to a Laplace equation. So this is your Laplace equation in the for your 2D soil, for an isotropic soil. What is anisotropic? Which is not having similar property. Which is not having similar property in all the directions. Okay. So there the coefficient of permeability in x and y can be different. But for isotropic soil, the kx and ky will be same, and if you are writing it here, then you can take kx thing common or ky thing common, then you will be getting that. H you can say is your head, x and y are the dimension. Okay, so that is the thing. Now, what is flow net? Flow net is just the graphical solution for this Laplace equation. Okay, you can solve this Laplace equation by various way. You can solve it by drawing graphically, which is flow net only, which you can solve by analytical as well, there are even more number of methods like electrical resistivity is also the method. So you can obtain the solution of these things by many ways. So after drawing the solution on a graph paper, whatever things you are getting, whatever blocks you are getting, whatever the boundary conditions you are getting, the graphical representation is simply going to give you the flow net. Okay, so that is the thing. So there are some properties of flow net. There are some properties of flow net. I will explain it. What are the properties of flow net? Yes, Ravi Kumar Gupta is saying, sir, it is a 2D analytical method. Yes, you can say, but analytical method we will not be studying. This is two-dimensional equation, and if you can solve this two-dimensional equation, then you will be getting its answer, or that solution will be analytical. But I am not going to solve that two-dimensional thing here with analytical method. Partial differential equation and all I do not have to use. I am simply going to use the you can say graphical solution of this. So the graphical solution of this equation or of this equation is your flow net. Basically it is this equation only, and if the equations comes in anisotropic condition, in that we have to revise our flow net. Okay. So there are some properties of flow net. Okay. So see, I will be drawing flow net here and I will be explaining you the things one by one. You know what happened when you are going in your soil system and all. Okay, just a minute. Just a minute. So, just a minute, guys. Yes, let's say these are your streamlines. Okay, and let's say these are your equipotential lines. See, you have to understand these properties very well. Okay. Okay, like this. Okay, you are having this, you can say equipotential lines, and you are having this streamline. I am going to call this streamline by this psi 1, psi 2, psi 3. Okay, you remember fluid mechanics? So streamline you are representing by psi, and let's say this is your equipotential lines. Okay, phi 1, phi 2, phi 3, phi 4, phi 5, like this. Means along this equipotential line your total head would be same. Along this phi 2 your total head would be same. So whether the flow is going to place from here to here or from here to here, it will depend upon whether phi 1 is greater than phi 2 or phi 2 is greater than phi 1. Okay. One thing is sure, if this is greater, then flow would be rightward, and if this is greater, then flow would be in this direction. Okay. So this will give you like that, because it is a common you can say rule of a nature that flow is always going to occur from higher potential to lower potential. Okay, so psi 1, psi 2, psi 3, psi 4, etc. these are the streamlines, means flow is going to occur along this streamline, and these are your equipotential line. Okay, so if you are considering any, you can say this field, this is known as your flow field. Okay, and these lines and these field is, you can say, forming by area enclosing between two consecutive streamlines and two consecutive equipotential lines. Is it clear or not? Okay. So totally you can say that there are three passages here. Passage number 1, passage number 2, passage number 3. Okay. So these passages are known as flow channels. What I am going to call them? I am going to call them flow channels. Is it clear? These are going to call as known as flow channels. And this is your flow field. I have observed here, if I am having 4 number of streamlines, then number of flow channels are 3, 4 minus 1. If there would have been 10 streamlines, then how many channels would have been here? Then it would be around 9, not around, exactly 9. Similarly, there are equipotential drops. Equipotential drop is also your number of equipotential lines minus 1. For example, if there are total 5 equipotential lines, then how many equipotential drop means how many times drop is going to occur? So this is your first drop, second, third, fourth. So total drops would be 4. So I can say simply that if ND is the, you can say, number of equipotential drop, or NF is the number of flow channel, then what can I say? I can simply say that so small nf and small d and d are your number of equipotential line and number of equipotential drops or equipotential lines. Okay, let me write it here. So this NF is number of flow channel, number of equipotential drops. Whatever I am telling to you, it is really going to be very important for you guys. Okay, so very all your numerical will be formed, you will be easily able to crack these numericals. Okay, but you have to rely on me. Whatever I am saying, you have to listen to that very consistently. Okay, so that is the thing here. Am I audible? Just a minute. Just a minute. Hello. Hello. Am I audible? Just a minute. Hello, hello, hello. Okay, audible now. Okay, okay, okay. Voice is not coming in my device. Okay. Okay, thanks. Okay. So I was telling you that whatever I'm going to say to you now, that thing is really very important for numerical point of view, and this is the topic in C page which is at top priority from numerical point of view. Okay. So these blue lines I have drawn here, and these are my streamlines, and these red lines which are almost perpendicular or orthogonal to these blue lines, they are equipotential lines. Okay, so along this line you can say your flow will be occurring, along this line your potential will be constant. So it is just like your that electricity thing, that flow is your current, and this is your potential drop. So current will only be flowing if there would be a potential difference between from here to here, then only your electron or proton will be moving from here to there, and they will originate current. Similarly, if there would be the difference in the elevation or difference in the total head, not elevation, if there would be the difference in the total potential, then only my discharge is going to take place, and that discharge is going to take place along my streamline, and it will be actually bounded between the flow channel and across the streamline, or you can say along the equipotential line. No flow can occur, because when all the water would be at same energy level, so it cannot you can say flow. Okay, suppose I am pouring some water at a horizontal level table, so do you think that water is going to flow? Why? Because on horizontal level table all the points are having same heads, okay, same energy level. But what will happen? But what will happen, my dear friend, when I will be inclining my table only just by a very little amount, still you will be able to, you can say, still you will be able to move your water will be able to flow there, because due to the tilting of table, the difference in the elevation, the difference in the total heads are there at various point. So now the water is simply trying to stabilize itself by going into from the higher potential to the lower potential. So that is going to be the case here, my dear friend. Is it clear? Okay. So let me tell you, if let's say from here to here the total drop is of FH, let's say from here to here total drop is, you can say, how much? H. Okay, and I am interested in writing the Darcy's equation. What is Darcy's equation? I know that Q is equal to K I A. Let me concentrate on this flow field. एक बार मुझे इस फ्लो फील्ड पे कंसंट्रेट करने दीजिए. इफ आई एम टेकिंग दिस फ्लो फील्ड आउट एंड आई एम एनालाइजिंग इट, it may look me like this. It will be looking like this. This is my one flow field. इसी को जूम करके बना रहा हूं मैं, इसी को जूम करके बना रहे हैं हम लोग यहाँ पे. So this is your equipotential lines and this is your streamline, and you are simply concentrating on the water which has been trapped in this flow field, and your water is taking entry from this side and it is taking exiting from this side. Okay, so this is the water in this flow field. Is it clear? So you know that Q is equal to KIA. Okay, you know your Q is equal to KIA. Okay, so the dimensions of this flow field, let's say it is A. Let's say it is also A, because it is also a property that all the flow fields are square. Okay, maybe sometimes it will not look like it would be your curved linear structures at all, but still here both the lengths are same and these angles are always remain 90 degree. I will come into the properties later. Okay, But before that, I am going to tell you a very important expression on which n numbers of numerical has been framed already in the past. So Q is equal to K is okay. What is my I? What is my I? We know that I is simply my hydraulic gradient. It is the ratio of head loss or head over a length, and this is equal to area. So can any one of you tell me, okay, sir, is it all flow channel are of same breadth? Yes, Ravi Kumar Gupta, exactly. They all are of same breadth, no doubt about it. They all are of same breadth. Is it clear? Yeah. Which you are saying now? Yeah. Now listen to me very carefully. What is this H? What is this H? You are saying that what is deciding the number of lines? Ravi ji, it is the boundary conditions. The extreme lines are going to be defined by the boundary conditions, and it is not about how much lines and how much you can say potential drops. This you can even increase. If you want to go in a more precise and you want to zoom it, then you can plot here more lines. Then you accordingly you have to plot here more streamlines, more equipotential drops. So still the identity would be same. Whatever you are going to get this. Okay, it is just like your camera. Now if you want to get good picture, the more you are zooming it and you are working final on the pixels, the picture quality is going to come good. Okay, but as long as we have to learn the basics, so in our question several streamlines and equipotential lines are given to us in that case. Okay, is it clear, my dear friend? So tell me, there would be some head difference between here to here, and that head difference is H. I want to write this H for this flow field in terms of you can say total head and all. Okay, great. See, if the total head between upstream and downstream, this is upstream and this is downstream, if the total head is H, can any one of you tell me in this particular diagram, in this particular arrangement, what is the drop from here to here? What is the drop from here to here? This is the question. I am asking you that if the total head between 5.1 to 5.5 is H, then how much head is going to take place between any two consecutive drops? Tell me. बताओ, कोई तो बताओ जल्दी. Okay, I am answering, you guys are not. So this is total as H. Let's say this H is H only. So how many drops? 1, 2, 3, 4. So in consecutive you can say drops, it would be H by 4. Because let's say if total this is 20 and there are 4 equal drops, then at each drop from 20 to it is 15, 15 to 10, 10 to 5, 5 to 0. So it is going to be like that. Okay, so total head would be if H, then between two consecutive drops it would be like K. You can write H like how much? You can write like H now, H over ND. Now what is L here? What is L here? This, yes, very good Ravi, very good. What is L here? L is that distance which your which your water has taken place. Okay, so your water has been through this length. This capital H by ND, or you can say H by 4, has been taken place due to the movement from here to here. So this much of head have been dropped, okay, when it is A, okay, let's say the dimension is A, yes, one flow field length. And what about the area? Area of cross section is this much, area of cross section is this much, okay. So this area of cross section is this much, so it is going to multiply it by area into perpendicular distance I can take at 1, okay. So if I am considering that how much discharge is there along the one flow field, then that is equal to, Q is equal to how much? Q is equal to K H over ND. But this is about one flow field. My dear friend, this is about one flow field. Okay, K H by ND. Okay, but my dear friend, this is about one flow field. If I have to calculate the entire discharge, then this is for one flow field, then entire discharge would be equal to this discharge only multiplied by number of flow field. It doesn't matter whatever discharge is acting here, it will also be same, here it is also same, here it is also same. So along the flow channel, this discharge is going to remain same, and when it comes to complete discharge of the system, let me write it by black, then this is equal to simply number of flow channel into discharge. So that is equal to KH NF over ND. KH NF over ND. So this is the expression for discharge. This is the expression for discharge, my dear friend. Okay. So the overall discharge along your flow net can be calculated by KH NF by ND. It is the very famous expression. You might have seen this expression a number of times in your BTech civil engineering. Okay, where K is the coefficient of permeability, H is the total head loss between upstream and downstream, NF is the total number of flow channel, which is equal to number of flow lines minus 1, and ND are the number of equipotential drops, which is equal to number of equipotential lines minus 1. Is it clear? So like that we can write the expression, and it is the very important expression. Okay, now let me come over to the properties. What are the properties saying? That first is two streamlines and two equipotential lines, they are not going to intersect each other. Second is flow line, yeah, it is true, two streamlines and two equipotential lines are never going to cross each other, it cannot happen. Next, flow lines and equipotential lines are orthogonal to each other. Flow lines and equipotential lines are orthogonal to each other. Okay, flow lines and equipotential lines are orthogonal to each other means these angle is always how much? It is always how much? 90 degree. Okay. Now, the area bounded between the flow lines is called flow channel. Exactly. I have used this term a number of times. So, this is one flow channel. This is second. The area bounded between two consecutive streamlines are known as flow channel. Okay. After that, the area bounded between two flow lines and two equipotential line is called flow field. I have already used that. I have taken this flow field out here, and this trapped area is known as now flow field. Okay. Other than this, the flow field is square for isotropic and for rectangular for anisotropic soil. That is also correct. Whenever I have to draw the flow field, it is going to be isotropic only, because this is going to be the solution of this. But whenever there is an anisotropic soil, means whenever we have to tackle such differential equation, there we are going to convert the scale, and we have to express you can say one permeability with respect to another direction. Okay, so that is Laplace equation would be square only, but that square dimension would be changed, one side would be changed depending upon the ratio of this permeability. So in short, whenever there is an anisotropic soil, then these flow fields will not be square, they are rectangular in that case. But from analysis point of view, we will be shrinking the longer side so that it can be equal to this side, and we will be analyzing it like that, and at the last eventually we will be able to keep the things after the conversion factor. Okay, that is the thing. And the last property is very important property, that your flow net is unique for the given boundary condition. For the given boundary condition, you would be having only one flow net. Is it clear? Even if flow direction reverses, okay, still your flow net would remain same. Suppose I am telling you this and this boundary condition remains same, so flow is going from here to here. Okay, but if somebody is saying you that soil is same, everything is same, boundary condition is same, okay, then what will happen? Or what will happen that even the soil, if the water has started to flow from here to here, then what would happen? If all of these material and soil are same, then still your flow net would be same. It is only that just like it is going to flow in the opposite direction now. Okay, so that is what it is written here. It is unique for given set of boundary condition and it is remain same even if the direction of flow reverses. So this is what I want to say here. Okay, so all these things are really very important properties of flow net, and I have shown you how we can drive the discharge for flow net. And for those who might be thinking that from there these blue lines and red lines are coming, so I want to tell them one more time. It is just obtained by solving the graphical, by solving this equation and plotting the results on the graphical line. So this solution comes out to be, you can say, two things. Somebody may also think that here is only h, here is only h, then how come here phi and psi can come? Okay, so you know that your potential function and stream function, where your velocity can be defined as the function of head only. Okay, your potential can also be defined with the help of velocity only, your head only. Okay, you may be remembering that fluid mechanics thing, that velocity stream function, okay, del h by del x, del h by del y, like that, vx vy, and there are potential functions as well. Okay, so from there you can convert, not an issue. So this is the thing, and this is the main thing which I want to highlight, that this is your discharge thing. It is really important. So whenever it comes to numerical, things becomes easier, because flow net problems, I would say it is very difficult to draw, but solution wise they are very easy. So it is a type of question which is taking more, you can say, time in framing question. So this is the thing. Okay, for example, see, if I want to tell you that q is equal to k h nf by nd, so only give me the value of nf and nd here. Okay, I am only interested in the value of nf and nd. What is there? You just tell me. See, you have to tell me the value of nf as well as your nd. What are number of flow channels and how many number of drops are here? You have to tell me this. So बताइए सब लोग. Okay. सो रवि जी कह रहे हैं कि सर एनएफ को कर दीजिए 4 और ड्रॉप को कर दीजिए 4. एनी अदर आंसर? थोड़ा सा एरर है. देखो यार, पानी कहां से घुसेगा? पहला ये चैनल बनेगा, दूसरा ये बन गया, तीसरा ये बन रहा है, चौथा ये बन रहा है, पांचवा. Is it clear? So total how many channels are here? NF would be 5, my dear friend. It is my first and it is my fifth. Here from here as well the water is going now. See this blue with blue, they are simply representing the flow line. So this is also your flow line. This is not the end is here. Okay, so they have covered the entire zone. So this is your fifth flow channel. This is your fourth flow channel. This is your third flow channel. This is your second. This is your first. Like this. So like this you can write the number of flow channel here. So total number of flow channels here are 5. If somebody asks you what is the total number of flow lines, you can say 6. Line number 1, line number 2, line number 3, line number 4, line number 5 and line number 6. Okay. So tell me if you are agreeing to me. So number of flow channels are 5 and F minus 1. Okay. Now let me talk about drops. Water is actually entering here. So here water must be at the same, you can say, energy level. It is entering from this side now. So initially here the energy would be same. So first drop is from here to here. So this is your phi 2. This is your phi 3. This is your phi 4. This is your phi 5. And this last one, this see they have written here in red now. So this is your phi 6. So one, let's say it is dropping here to here 1 meter. So 1 meter, then 1 meter, then 1 meter, then 1 meter. So total how many lines? 1, 2, 3, 4, 5, 6. So total number of equipotential drops are 6 in number. But if you want to, sorry, equipotential lines are 6 in number, then the number of equipotential drop would be ND minus 1. It would be how much? First drop, second drop, third drop, fourth drop, fifth drop. क्लियर है कि नहीं है? अरे बोलिए भाई. बस आपको यही कैलकुलेट करना है. Only these things you have to make sure. You have to make sure you are doing the correct counting and all. Otherwise, Flownet's problems are nothing. They are simply KH and F over ND. Or if the mathematical formulation is coming, then it is going to be a very rare, very easy, one-dimensional differential equation question. Sir, if distribution is not uniform, so how we are going to calculate the drop? Nurul Amin saying, sir, if distribution is not uniform. If distribution is not uniform, Noor, I am considering that you are talking about non-uniform permeability. I think you are talking about non-uniform permeability, I guess. So if permeability of the soil is not uniform, then it is true that this is not coming out to be square. This is not coming out to be square. It would be coming, you can say, rectangular. Okay. It would be coming there as your rectangular thing. So there what would be happening? We will be converting our one width is Rabjeet bhai kaise ho? Hello. Some types of another width. Okay. So from here we will be drawing a square only, but later on solving the all things. In the end we will be replacing b is equal to some n times of a. This b may be anything. It may be ky over kx like that. Okay, that is a conversion factor. Okay, what I will do, I will try to take one numerical for non-uniform condition. For anisotropic condition, I will take a numerical and explain you that. Okay. So in next class, I will take numerical. Okay, on non-uniform. And once again I am reminding that tomorrow I do not have any class. I will be taking my next. I am not having tomorrow this class. You can say Geotechnical. Okay, so tomorrow Mrigam Sarav sir will take my slot. Okay, and Ravi is asking, sir, please explain the boundary condition. Ravi, boundary condition is this, that you have to only focus on the boundaries, that what is happening at the boundaries. What do you mean by boundaries? Boundary for me is entry point, boundary for me is exit point. I think these two are the boundaries only in my flow. Entry, exit. So if I am see here, okay, see, this is your entry, this is the exit. So at entry, this is the same potential level, because when water is entering here, see, this is the red line, huh? It is first, it is second, it is third, it is fourth, it is fifth, and it is sixth. Okay, and lines are first boundary line, topmost flow field, flow streamline, second, third, fourth, fifth, and this is last, sixth one. So there are total number of equipotential lines were 6, and streamlines are also 6. So drops and you can say channels are 6 minus 1 and 6 minus 1. So like that we can calculate, we can count the NF and ND depending upon the boundary condition. Okay. Okay. So before that, let me ask you one question. So I have a question for you. So today already 9:35 is there. We have not done even a single numerical. So try to answer this. The flow net around a sheet pile wall is shown in this sketch. The properties of the soil are permeability coefficient of 0.09 meter per day, isotropic, specific gravity is 2.7, and void ratio is 0.85. The sheet pile wall and the bottom of the soil are impermeable. And what is going to be the seepage loss of the water? What is going to be seepage loss of the water? Okay. See, this is the upstream condition. So this is your entry. This is your entry. This is your exit point. So you only have to see, or you can say you only have to count total number of equipotential lines as well as equipotential flow lines. Only these two things you have to count, then remaining question is nothing. Remaining question is nothing, my dear friend. Okay, just try to think over this. What is going to be the approach here? Is it clear? So just give me the value of NF and ND. Rest I think it's quite easy. Okay, maybe I'm hiding some of the options. So what can I do? Now it is okay. Option A, B, C, D, and I want to clear out this space. Okay. So tell me guys, I am only interested in knowing how much is the NF here and how much is the ND. First of all, tell me only this thing. Rest of the things are nothing here. Number of flow lines, seepage loss you have to calculate in meter cube per day. How many number of flow lines are there? See, entry, exit. Okay, first, second, third and fourth. So total number of flow channels are 4 and number of lines are 1, 2, 3, 4, 5. Along this sheet pile is going to be your top flow line and this bottom boundary is going to be the bottommost flow line. Now what about drops? What about drops? It is entry, it is exit. The total head is of 8.5. Okay, at entry it is 8.5 and at exit it is 1.5. Total head difference is of 8.5. And my dear friend, this is first drop, this is second, this is third, this is fourth, fifth, sixth, seventh, eighth. So total drops are 8, and if somebody asking you how many lines are there equipotential, then you can say 9. First line, second line, third line, fourth line, fifth line, sixth line, seventh line, eighth line, ninth line. So out of the total these 9 lines, you can say that number of drops are 8. So Shamala has given the answer. Let me check it. So Q is equal to, you know the coefficient of permeability, it is isotropic, it is 0.09 meter per day. What is H? 8.5. Total head difference between upstream and downstream side. What is NF? It is 4. What is ND? It is 8. So this head is also in, you can say, this head is also in, you can say, meter and all. Okay. So that is the going to be the case. So this discharge you would be getting in meter cube per day. So how much it is, you can calculate it. Okay, you can calculate it. It is going to be 0.3825 meter cube per day over meter, because here meter square na, so perpendicular to one dimension 1 meter, you have to take meter cube and you have to divide by meter. Okay, so this is the Q thing, my dear friend, this is the Q thing. Is it clear? So which option? So we would like to go with option number B. Is it clear to all my dear friends? Let me know. Okay, then here is question number 2. Here is question number 2, my dear friend. बताइए. This is a good question. You have to calculate the factor of safety against the okay. So any answer? Dear Ravi, this piping failure is nothing, just your boiling condition and critical condition. I have taken this thing in yesterday's class. It is nothing but your quicksand condition. When piping will be happening, see, if you are having here a lump of soil mass and maybe your water is dragging the surrounding soil, so a cavity will be created here. So this cavity is known as piping only. Okay, so you want to prevent this piping, you can say. Then for that what you have to do, you have to calculate the factor of safety. So this factor of safety is simply given by because piping phenomena is occurring at the exit only, where the lack of confinement is there, because these things will not be there in the entry point or between thing. Here the soil having much chances of erosion and all, so we have to calculate this piping at exit. Okay, so this is simply equal to critical hydraulic gradient upon I of exit. If critical hydraulic gradient, it is a requirement, if it is greater than exit, then it is okay, we are safe. But if I exit is greater than I critical, in that case you will be saying that you are it is going to be unsafe. So that is going to be the funda here. Okay, so first of all let me calculate the ICR value. How I am going to calculate? I am going to calculate the ICR value, that is important. So Sabia Yasin is saying that she would like to go with option C. Okay. Okay, 2.6. Good. 2.6 is the right answer. So see, this ICR is equal to G minus 1 upon 1 plus E. And those who are joining me first time today, so they can watch to my earlier lectures for references. So it is the last lecture of C page, but now I want to bring one practice session on permeability and C page, where I would also like to cover that problem, two-dimensional problem. So it is 2.65 minus 1. Okay, good Ravi. 1 plus void ratio is 1.85. So it is coming out to be how much? Let me verify it. Point. Okay. Okay. 918. Okay. Now I have to calculate. Listen to me. I have to calculate I at exit. See, this is very important. This is very important. Yes. Okay. How you are going to calculate I at exit? This is important. See. First of all, pick up the last flow field. So if I am considering this one, because this is the flow field at exit, or you can say this is the flow field at exit. So how much is the, you can say, length from here to here? They have given you, it is how much? It is 3 meter. If you are going to draw like this is your flow field. This is your exit flow field. This is your exit flow field. Okay. So here the water is entering and here the water is exiting. So this dimension is 3 meter. So what is I exit? I, you know, hydraulic gradient. Hydraulic gradient would be equal to how much? It is the head loss over the length. How much head loss would have been occurring here, or what is the available head at the upstream of this entry? So total it is dropping out to be 10 minus 8.5, 8.5. So 8.5 meter head loss, you can say head difference is originated for 8 number of drops. Then for 1 number of drop it would be how much? Then for 1 number of drop it would be how much? It would be 8.5 over 8. So this is the head drop for here. I can keep it see, I exit is equal to, very good Sabia, very good. It is equal to how much? It is equal to H by L. So total H for 8 drops is how much? 8.5, 10 minus 1.5. So for 1 drop it is how much? 8.5 over 8. So this H is how much? 8.5 over 8. Now what is the length? How much it has to travel for this 8.5 over 8 head loss? It has to travel from here to here. So what is the length? So length is 3 meter. So what is this value? I exit value is how much? What is this value? How much is this I exit? If you are going to calculate this, it is going to be equal to 0. How much? 35. Okay. So 0.35. So now it's the factor of safety. So factor of safety is simply your ICR at I exit. This is equal to 0.918 over 0.35. So answer is coming out to be how much? So you guys are saying 2.6. So I am also relying you. 2.6 is the right answer. 2.6 is going to be the right answer. Is it clear to all my dear friend? Tell me. Okay. Okay. So practice session I will be taking on you can say seepage and permeability. Okay. Okay. Good. I hope Ravi now you got the concept. I hope you got the concept now. चलिए कोई नहीं. Okay. Good. So guys, I having one more question on consolidation, but that I will take later. Okay. So yes, let's wind up the session, my dear friend. If anyone wants to crack GATE ESE by following our YouTube, he or she can do, because here we have given almost our all comprehensive courses. If I'm talking about me only, my RCC is there, my structural analysis is there, my crash course on SOM is there, Geotech is ongoing, Geotech new portion is also I have done, in which laterally loaded piles and all are coming. So not only my subject but other educators also complete their structure, you can say playlists. Okay. And if I'm talking about the GATE 2022, then Evolve batch is there, which we have started on 22nd of February. And if you want to be a part of these batches, then you can use the code S10. Okay. And if you are targeting yourself for GATE 2023, then Ascent batch is there, and which also started on date 22 Feb 2021. Here as well you can see that our top educators are going to initiate this batch. So we can have a small informative video on this, only 30 seconds. So you can get your subscription now, and you can use and promote my course code among your friends and relatives. Okay, and this batch is there for your general studies thing, my dear friend. Here the non-technical subjects are also being taught in so much of detail by our top educator, and this batch we have started approximately a week ago on 18th Feb, you can say. And all these are the educators which are going to take lead in this batch. Here as well you can use my code S10 to be a part of this, and you can get 10% discount. Okay, regarding the prices of subscription, it is for 1 year you have to pay 27,225. For 1.5 years you have to pay 34,650, and for 2 years you have to pay 39,600. So these are the prices which you have to pay after applying my code S10. Otherwise you have to pay 11.11% extra. Okay, is it clear? Because these are the discounted rates, these are the 10% discounted rates. Okay, so similarly, if you want to go for an iconic plan, in that case I would like to say for 1 year you have to pay 45,225. It is 45,225, and for 2 years it is your 66,600. And why iconic is expensive, that I have told you at the beginning, because here we are going to assign you a local guardian, okay, who is going to take care of your studies and planning your studies. Is it okay? And this is, you can say, you can follow me at Unacademy. You can follow me at Unacademy always, my dear friend, at the rate Sharma Aishwary -1049. And this is our official Telegram channel. I am going to send daily notes and all at this channel. And all these are the channels offered by Unacademy free of cost, so that we can bring the revolution in our study thing. And right now you guys are watching me at Unacademy GATE CESE, which is known as the one-stop solution for all your engineering problem. So thanks a lot, my dear friend. Thank you. Have a nice day. Have a great day. Enjoy your day and stay safe. Don't go outside if it is not required. Bye bye. Take care.